Amazing! This is SirBas of SirBas TV. In our previous video, we were able to describe motion using visual representation in the form of ticker tape diagram, which is also known as that diagram. In this video, we are going to visualize motion using graphs. Are you ready to learn? If you find this video helpful, please do not forget to subscribe to this channel. Do not forget to like, share, and comment #AgAmazing. Let's go! Aside from diagram, the motion of an object can also be represented using graphs. In physics, these are called motion graphs. A graph is a visual representation that uses lines to show how two or more sets of measurement are related to each other. In this video, we are going to use lines on two axes, the x-axis and y-axis. To make sure that the information is properly represented in a graph, a graphing paper is usually used. A graphing paper has precise squares and presents the information in an accurate manner. To understand how a graph works in representing motion, let us try graphing the following data. The table below shows the position of the ball in a given time interval. To represent the motion of a ball using a graph, we need to plot this given data. In this Cartesian coordinate, we have x-axis and y-axis. The time interval will be plotted on the x-axis and the position of the ball will be plotted on the y-axis. Let us start plotting the given data. At 0 second, the ball is positioned at 0 meter. So we are going to plot this data on this point. Next is at 5 seconds, the ball is positioned at 5 meter. We are going to locate 5 seconds on the x-axis. In this case, here is the location of 5 seconds. I will draw a vertical line to serve as guide. Next step is to locate 5 meter on the y-axis. Here is the location of 5 meter. If you already mastered the plotting of data, you do not need to draw a vertical line. We are doing this step to easily locate the point of intersection. The point where the vertical lines of x and y-axis intersected is the place where we are going to plot the point. So in this case, we will plot the point in this place. Perform the same steps on the remaining data on the graph. You can remove the vertical lines that we drew a while ago since they are just guidelines. After plotting all the given data, draw a line through the points in the graph. Now you have created a graphical representation of the motion of the ball. The graph that we just created is an example of position-time graph. We can use this graph to describe the position of the object at any given time. For example, if you are asked to find the position of the object at 10 seconds, all you need to do is to find the point along the diagonal line where the vertical line at the 10-second mark intersects. Then, find the horizontal line from that point of intersection that will cross the y-axis, which is the position axis. This will give you the position of the ball at 10 meters. When a graph is plotted in terms of distance traveled by the object and the time it took to cover such distance, the graph can be called distance-time graph. If the graph is plotted in terms of displacement and time, it is called displacement-time graph. The line that connects the points in a graph is called the slope. The slope in a graph gives us an idea about the motion of an object. Let us study the following slopes in a graph and their corresponding interpretation. The slope of a position-time graph gives us the velocity of an object. If the slope of a position-time graph looks like this means that the object moves at a constant or uniform velocity. Uniform velocity can be observed if the object travels equal distances in equal time intervals without changing its direction. The graph also indicates that there is a zero acceleration. Next is this graph. The slope in this graph indicates that the velocity of the object is zero. This may mean that the object has not changed its position or has not moved from its location. Observe this graph. What can you say about its slope? Correct. It does not show a straight line but a curved line. The curve indicates that the motion or the velocity of the object is always changing. If the quantities involved in a graph are velocity and time, this is called a velocity-time graph. The slope of the line pertains to the acceleration of the object. This velocity-time graph indicates that the motion is uniform acceleration. The velocity of the object is changing at a constant rate. The next graph shows zero acceleration. This also means that the body is moving in uniform or constant velocity. This graph indicates that the acceleration of the object is not constant, and the acceleration is increasing. And lastly, the slope of this graph indicates that the object is decelerating. And that ends our discussion about describing motion using graphs. Remember that the slope in a graph describes the motion of the object. In our next video, we are going to discuss about waves. See you on our next science lesson. Amazing!